Hello everyone, in the last video we talked about addition's principle. In this video we're going to continue with lecture 5 with multiplication principle. I want to reiterate that when you use addition principle you choose between different categories or options, and you use multiplication principle when you want to build sequences step by step. Now, the definitions of multiplication principle is that if an event A can occur in m ways, and each possibility for A allows for exactly n ways for B, then the event A and B can occur in m times n ways. So that's the definition of multiplication principle, but let me give you a quick example to illustrate the point. So suppose a restaurant offers 3 types of burgers. You can have beef burgers, you have chicken burgers, you have veggie burgers, and 2 choices of drinks including soda and juice. So you have the choice of beef, you have the choice of chicken, and you have the choice of veggie. And if you choose to order the beef burger, there are 2 possible drink choices. You can choose to drink soda, or you can choose to drink juice. Similarly, for the case of ordering the chicken burger, you can later choose to drink soda or juice. And when you order the veggie burger, you can also have the choice of drinking soda or drinking juice. Then for the first event, there are 3 possibilities that can occur in the first event. So there are 3 choices in the first event, and for each choice in the first event, there are 2 choices in the second event. And the number of possibility for event A and event B is going to be 3 times 2 equal to 6. So there are 6 possible meals from this list. Right? So again, the first choice should be either beef burger, chicken burger, or veggie burger. And for each burger choice, there are 2 possible drink choices. If you choose beef, then go with soda. You have beef plus soda. If you go with beef and then juice, you have a meal of beef plus juice. Then chicken plus soda, chicken plus juice. Then veggie plus soda. Then veggie plus juice. And altogether, as you can see, there are 6 possible meals that you can generate from this event. Now I'm going to move on to another example. In the last video, we talked about a large language model choosing a word after a phrase, and the word can be chosen from different categories. Instead of choosing just one word from different categories, what we want to do now is that we actually want to generate sentences. Suppose for this simple example, I want to generate a 3-word sentence and I want to know how many ways that I can do that. So suppose an LLM generate 3-word sentences. So there are 10 choices for the first word, 20 choices for the second word, and 5 choices for the third word. Alright, so this sentence going to have 3 words, and I indicate that by 3 different slots here. For the first slot of the first word, there are 10 choices, and for the second word, there are 20 choices, and on the third word, we have 5 choices. Therefore, the total possible 3-word sentences are going to be 10 times 20 times 5 equal to 1,000. So 10 times 20 times 5 equal to 1,000 possible 3-word sentences. Alright. So again, you use multiplication principle in the case of you want to build a sequence step by step. In this case, there are 10 different ways to have the first step, then 20 different ways to have second step, and then 5 different ways for the third step. Now let's move on to another example. So in this example, I want to introduce to you a telephone numbering plan in North America. So North American numbering plans specifies the format of telephone numbers in the US, in Canada, and many other parts of North America. And the telephone number in this plan consists of 10 digits. 1, 2, 3, 1, 2, 3, 1, 2, 3, 4. So this is going to be 10 digits. Because of signaling considerations, there are certain restrictions on some of these digits. To specify the allowable format, we're going to let X denote a digit that can take any of the values from 0 through 9. So 0 to 9. And we're going to let N be a digit that can take any of the values from 2 to 9. And capital Y denoted as digits that must be either a 0 or a 1. So we're going to have two different plans here, the old plan and the new plan. So the old plan is in use in the 1960s, and that has been replaced by the new plan. In this example, the letter used to represent digits follow the convention of the North American numbering plan. So this is the format that we're going to use. So for the old plan, the setup is going to be N, Y, X, N, N, X, and X, 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 X. And for each letter, that's going to consist of the number from this list, right? So when you have N, that means you're going to choose the number between 2 and 9. For Y, the number is going to be either 0 or a 1, and X is going to be the number between 0 and 9, so on and so forth. Now for the new plan, you're also going to have the North American numbering system. And the format for the new plan is going to be N, X, X, N, X, X, N, X, 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 X. Now for the old plan, the first digit is going to be N, so there are 8 choices going from 2 to 9. For Y, there's only 2 choices, it's either 0 or 1. For X, there are 10 choices, again N is going to have 8. And again, you have 8 different choices for that number, and X you have 10 different choices. And for the last 4 digits, you have this to be 10 choices for this number, 10 choices for this number, and 10 choices for this number. Together, we're going to have 8 times 2 times 10 times 8 times 8 times 10 times 10 times 10 times 10 times 10 here. And the result is going to be 1 billion and 24 millions. So again, there is 1,024,000,000 different numbers available in North America. Now under the new plan, so the first digit consists of 8 different choices. For the second digits, we have 10 different choice. The third digits, you have 10 different choice. For the fourth one, you have 8 different choice, so on and so forth. I'm going to fill out these choices here. And for the new plan, there's going to be 8 times 10 times 10 times 8 times. Okay, and that's going to give you 6,400,000,000 different numbers for the new plan in North America. Now I'm going to move on to the last example, and I want to incorporate both addition principle and multiplication principle into this example. So we know that in the NBA, the National Basketball Associations, there are 30 teams in the NBA, and for each team they play 82 regular season games per season. Right. And how did the NBA come up with that particular number? So they have a few different categories they need to follow. For a team like Boston Celtics, all four division rivals are played 4 times. The remaining 10 conference teams in the Eastern Conference are split into 6 teams play 4 times, 4 teams play 3 times. And the choice of 6 team and 4 team very much depends on the schedule rotation, competitive balance, travel considerations, and a few other things. And all 15 opposite conference teams, which is in the Western Conference, are played 2 times. And based on this category, we can build up the schedule that leads to the fact that the Boston Celtics plays 82 regular season games per season. So this is going to be category 1. This is going to be category 2. Because the remaining 10 conference teams split into 2 different categories. And this one is category 3. And the last one is category 4. Now for category 1, you have that all 4 division rivals are played 4 times. So in the Boston Celtics division, which is Atlantic divisions, you have, of course, the Boston Celtics, the New York Knicks, the Brooklyn Nets, Philadelphia 76ers, and the Toronto Raptors. And because we're talking about the Celtics, and the Celtics have to play 4 different division rivals, and each we're going to play 4 times. And each rival we're going to play 4 times. So there's going to be 4 times 4 equal to 16 games in the first category. Now, in the second category, 16 played 4 times. So that means the Celtics are going to play 4 times with 6 different teams in the same conference. So now in the second category, you have 16 times 4 games equal to 24. And in category 3, we're going to play 4 teams, and each team we're going to play 3 times. So 4 times 3 equal to 12. And in category 4, in all 15 Western Conference team will play 2 times. So 15 times 2 equal to 30. And because we choose from this different categories, the total number of games in the entire regular seasons is going to be 16 plus 24 plus 12 plus 30 is going to give you 82 games in the regular seasons. I hope this example will help you understand the connections as well as the differences between addition principle and multiplication principle. For multiplication principle, you have the teams multiply with the games per opponent. And for addition principle, you add different categories of games together to arrive at the final games for the regular seasons. So that's it for me for this video. Please let me know if you have any questions.